Okay, hello students. I hope you all are fine. So let us see this question. Which is a vector quantity? And the question is, and the options are number one, pressure, number two, electric current, temperature, and magnetic field, which is a vector quantity. So first of all, the question is like which physical quantity can be regarded as a vector? See, there are three different conditions which have to be satisfied by the physical quantity to be taken as a vector quantity. What are those conditions? So I'm writing these conditions here. Number one, they all must have directions. So this is a very famous condition, so everybody knows it that the vector quantities have direction, but this is not the only condition. Now here is the crux. Now point number two is they should all satisfy the vector law of addition. They should follow the law of vector addition, so which we do in the chapter vectors. So that has to be fulfilled. This is the number two condition, and the third condition is that the addition should be commutative. Commutative. Now by commutative we mean that a vector plus b vector should be equal to b vector plus a vector. So if these three conditions are fulfilled, the physical quantity will be taken as vector quantity. Now, when we talk about pressure, we know that pressure is not a vector quantity, although it has direction. So if I ask you where is the pressure, if this is the atmospheric pressure we're considering, let us say, where is the pressure on the wall behind? Obviously it is 90 degree to that. Where is the pressure on the floor? It is 90 degree on the floor. So there is a direction of the pressure, this physical quantity, but this direction, this physical quantity does not fulfill the condition number two, which is the it does not follow the law of vector addition. So that is why pressure is not a vector quantity and it is considered as a tensor quantity. Now, tensor quantities are those physical quantities which have direction, but still they are not vector quantities. So there are books available which say that pressure is a tensor quantity, so there is no doubt about it. Next is electric current. Now, same with the electric current does have a direction. If there is a straight wire, we can say that either the current is moving towards left or it is moving towards right. So there is a direction of the current, but because it does not follow the law number two and number three, that is why even this physical quantity is not considered as a vector. So this can be taken as a tensor quantity, but there is very less mention about the current for being tensor quantity in our books. So that is why we must not say it, but it can be regarded as a tensor quantity, but it is not a vector quantity. Now the third quantity is temperature, and we all know that temperature is a scalar quantity. There is no doubt about it. So we are left only with the fourth option, which is magnetic field intensity. The magnetic field intensity is given by B, and it is written like this: B vector. This is to be covered in the syllabus of a second year for IB. So that is why, because this topic vector belongs to the first year, magnetic field will be completed in the next year. So that is why it is the possibility that you don't know what is magnetic field. But this will be the answer. So our answer is D. We are absolutely correct. So all the best. Bye.